We ended the last video going over the area of a rectangle, which is length times width. And we found out on this one a 3x4. To find out the actual area of the rectangle, we substituted or put a 4 in place of the length and a 3 in place of the width. We talked about how we could have had a 3 here and a 4 here and still came up with the same answer. We also talked about taking apart or decomposing a number. Okay, so we went through, I'm going to turn on the light. We went through some different ways of decomposing the number 50. Then for your assignment and your homework, you had decomposing the number 24. And since most of you have not turned in your assignment, we will not go over that. But it's the exact same way as doing 50. For new material today, we are going to learn about the distributive property. We're going to work through an example and develop the distributive property rather than me just giving it to you. So, we are starting out with a rectangle that is 5 by 15. We're just going to go through and find the area of this rectangle. We can say, I'm going to say the length is 5 and the width is 15. But we know from our previous examples that we can use the blank property to write this as 15 times 5 if we wanted to. What property was that? I'll let you think for a second. If we just flip-flop the numbers around, what was that property? The commutative property. Commutative property. That's how we abbreviate it right there. COMM and then PROP. Okay, so if we continue, 5 times 15 is 75. And since we're finding area, we've already talked about this. 75 square units. If you can't remember that, you need to go back and watch the previous video. So 75 square units. Okay, so we are going to begin developing the distributive property right here. Draw a line to split one side length of the rectangle, into two parts to represent 75 square units. Label the new regions. All that is asking us to do is to split this rectangle. We don't have to split it in half. We can split it however we want. So I'm going to draw the rectangle here again. I'm trying to make this extra dark because this new dot camera is not super nice. Okay, so I'm going to take the side that was 15 and I'm going to split it. Okay, let's divide it into, let's do 10 and 5. So let's divide it right here. Let's make this segment length 5 and let's change this one into 10. So we decomposed the number 15 into 5 and 10 because we know that 5 plus 10 will get us 15. So even though this is two separate figures, we still know that that is 15. It's just labeled different. Okay, so our next part, in order for us to come up with the distributive property, we are going to rewrite our 5 times 15 equals 75, which was this here, 5 times 15 equals 75, we are going to rewrite with an equivalent equation. Okay, equivalent meant equal. Equation meant we had to have a equal sign. We talked about that last week. So we're going to rewrite 5 times 15 equals 75 as a equivalent equation to represent our new picture. Okay, so I'm going to say, well, I'm going to give you just a minute and let you think about what I just said. Okay, so previously we did 5 times 15. Okay, so we did 5 times 15, and we have to write an equivalent equation. So it has to be equal. And how about we do 5 times, that's what the parentheses mean. If we have parentheses right next to a number, it means times 5 plus 10. Okay, the reason I knew to do that was this side says 5 times 15, and this side says 5 times order of operations, parentheses are first, 15. We just wrote it different. It says the same exact thing. 5 times 5 plus 10. That's still 15. Okay, now the next part of developing this distributive property, I have down for us to rewrite the total area as the sum of the two smaller regions. Okay, rewrite the total area as the sum of the two smaller regions. All that is asking us to do is sum the two smaller regions. Okay, so we're going to take this 5 times the quantity 5 plus 10, and we're going to work it out. We begin by saying 5 times 5. Okay, so I'm going to draw an arrow here. Whenever I do this, I say 5 times 5. We come up with 25. I have an addition sign, so I put that down. And then I say, okay, what's 5 times 10? That's 5 times 10. 5 times 10 is 50. Okay, that is the distributive property right there. You're distributing a number into these parentheses. Okay, so 5 times 5, we got 25. 5 times 10 is 50. I would imagine somebody saying, how do you know to multiply? Okay, so outside here, we previously discussed that when there's a 5 or any number right next to a parenthesis, even though it doesn't have a multiplication sign, it doesn't have an X, it doesn't have a dot, it still means multiply. So that is how I know to do 5 times 5 and 5 times 10. Okay, and I copy the addition sign in between them, and then I just add them up. 25 plus 50 is 75. That's how we know it's equivalent, because look, 5 times 15 was 75, and that's what we got. So we know we have it correct. Okay, let's move on here. Use your area model to complete this example. Okay, 15. 5. Okay, so let's look at this first line. I'm going to try to cover this up, but I think it may make it a little easier. Okay, so the first line is asking us to break apart 15. Okay, well, how did we break 15 apart in our example? We used 5 and 10. Okay, our next line is showing us that we really need to be doing 5 times what number plus 5 times what number? This is what we just did. 5 times 5 plus 5 times 10. Okay, well, the next line has blank plus blank. Well, that means we're supposed to work out this section. What's 5 times 5? And what's 5 times 10? And then we just have an equal sign. 25 plus 50 is 75. So this example is exactly the same as what we did right here, just a little bit more detailed. Okay, so from here to here, same thing. Same with more details. Okay, so we have figured out the distributive property. We are going to do a couple more examples before we are finished with this. Okay, so the distributive property over multiplication. This is our first example. To properly read this, we would say 5 times 5 times the quantity 10 plus 15. So to properly read it like a mathematician, when we see parentheses, we say the quantity. So 5 times the quantity 10 plus 15. Okay, our first step is to do 5 times 10. We bring our plus sign over, and we do 5 times 15. We come up with 50 and 75. So we add 50 and 75, which comes up to be 125. Yeah. Okay, our next example, 4 times the quantity, 2 plus 15. We do 4 times 2, bring our plus sign over, and then 4 times 15. Okay. 4 times 2 is 8. 4 times 15 is 60, which gives us 68. By the way, we know to multiply this and this before adding them together because of the order of operations that we've previously covered. Okay, last one here. 3 times 6. Oh, I'm sorry, I didn't read the problem. 3 times the quantity, 6 plus 5. So we start with 3 times 6, bring over our plus sign, and then we're going to have 3 times 5. 3 times 5. 3 times 6 is 18. 3 times 5 is 15. That gives us a total of 30, let's see, 33. We're not going to do the very, very last one. So that is it. Refer back to Google Classroom for the rest of your assignment.